Hello everyone, this is Teacher Michelle and welcome to another episode of Unang Math. For this episode, we will still be solving complex linear inequalities, but this time, the coefficient of x is a variable. Okay, take a look at this first example. Solve the linear inequality ax plus 2 is greater than 0 for x when a is greater than 0. Okay, if we are solving linear inequality wherein the coefficient of variable x is a variable, what we need to do is think that this coefficient is a constant number. Okay, and then consider the condition. In this problem, the condition is a is greater than 0. It means a is a positive number. Okay, let's solve this linear inequality. First, we have to transpose 2 on the right side of this inequality. So we only have ax on this side. This is greater than negative 2. And since we're looking for x, we will be dividing both sides of this inequality by a. And if we will simplify, x is greater than negative 2 over a. Our symbol will not change because the value of a is positive number. So this is x is greater than negative 2 over a. Okay, what about the second example? Solve this linear inequality. Ax is greater than 4a for x when a is less than 0. If a is less than 0, then it means a is a negative number. Okay, now let's solve this inequality. We're looking for x. So we have to divide both sides of this inequality by a. And if we will simplify, we have x on this side. 4a divided by a, then this is 4. And take note, a is a negative number. So it means we divided both sides of this inequality by a negative number. So from greater than, then our sign changes or reverses. So this is now x is less than 4. Okay, another example. Let's solve this concept check question. The following is the process of solving this linear inequality. Ax plus 2 is greater than x plus 6. For x, when a is less than 1, we will fill in the box with appropriate values. So this is our linear inequality. Ax plus 2 is greater than x plus 6. Okay, to solve this one, we will be transposing 2 on the right side and x should move on the left side. So we have here ax minus x is greater than 6 minus 2. And to find the coefficient of x, we need to factor out x. So this is ax minus x. To find the coefficient of x, factor out this expression. So inside the parentheses is a minus 1. So that's the coefficient of x. So this is a minus 1 inside the parentheses. Okay, x is greater than 6 minus 2 is 4. Okay, now we are looking for x. So we will be dividing both sides of this inequality by a minus 1. And if we will simplify, we have here x, and this is 4 over a minus 1. And then now, a is less than 1. So it means we are going to reverse this symbol. So from greater than, this now becomes less than. So x is less than 4 over a minus 1. 4 over a minus 1 cannot be simplified anymore. So this is now the answer. Or 4 over a minus 1 cannot be factored out already. So this is now our final answer. Okay, but if you got an expression like this, for example, we have here 12 minus 6a, okay, over 2a minus 4. Okay, this is not yet the final answer because we can still factor this out. So, negative 6 is outside and inside the parentheses is a minus 2. Okay, what about 2a minus 4? So, 2 is outside and then inside the parentheses is a minus 2. And if we will simplify negative 6 divided by 2, then this is now equal to negative 3. Okay, but since this expression 4 over a minus 1 cannot be simplified or cannot be factored out, then this is now our final answer. Okay, this time, let's answer the following problems. So the first problem is, find the value of the constant a if the solution to the linear inequality ax minus 4 is less than 8 for x is greater than negative 2. So in this problem, they already give the solution, which is x is greater than negative 2. So our aim is to find the value of constant a. Okay, then let's solve this inequality. So using transposition, move this negative 4 on the right side of this inequality. So we only have ax on this side. This is less than 8 plus 4. Okay, 8 plus 4 is 12. So this is ax is less than 12. And we are looking for x. So what we need to do is we will be dividing both sides of this inequality by a. And if we will simplify, we only have x on the left side and we have 12 over a on the right side. Okay, since x is greater than negative 2, then that means this sign changes to greater than. Okay, what will be the value of a to make x is greater than negative 2? So it means a is a negative number and a is negative 6. So 12 divided by negative 6 is negative 2. So x is greater than negative 2. So the value of the constant a in this inequality is negative 6. Okay, how about the second problem? Find the range of values for the constant a if the number of natural number solutions for the inequality 5x minus 2a is less than or equal to 4x minus a is 3. So according to this problem, there are 3 natural number solutions for this inequality. So our aim is to find the range of values for the constant a. Okay, let's solve this inequality then. So 4x should move on the left side of this inequality and negative 2a on the right side. So we have here 5x minus 4x. This is less than or equal to negative a plus 2a. Okay, let's simplify. 5x minus 4x, then that's x. So x is less than or equal to negative a plus 2a is a. So x is less than or equal to a. Okay, we are looking for the range of values for this constant a. Okay, on the number line, take note, natural number. Natural numbers are 1, 2, 3, or counting numbers. And there are 3 natural number solutions to this inequality. Okay, let's say A is 3. Since this is less than or equal to, it means 3 is included in those numbers. So we have 2, 1, take note, 0 is not a natural number. So, if x is less than or equal to a, and if a is 3, then we have 1, 2, 1, 2, 3. So there are 3 natural number solutions. Okay, how about if A is, let's say, 3.5? So this is x is less than or equal to A. So if A is 3.5, then still we have 3 natural number solutions. Okay, but what if A is 4? Okay, take note, our symbol here is less than or equal to A. So it means 4 is not included in those range of values. So A must be, okay, greater than or equal to 3, but less than 4. So the answer to this problem is the range of values for constant A is A must be greater than or equal to 3, but less than 4.